Hello everybody, Chaz Large here with another video for you, and on the bench today we have got three Fluke digital multimeters. Yes indeed, these are good old Fluke 8000A bench multimeters, which I managed to purchase off of eBay for a grand total of £20. With the in the condition it said 3 meters may get one going out of 3, so I thought, well, blimey, that's got to be a bit of a challenge. So they arrived yesterday. I've had a brief little look at them, and apart from being filthy, there are bits and pieces for all of them. This one here, which has not got any cover on and appears to have various bits missing from this side, and is, as you can see if I show you from over the top, it's got, just get that focused. So as you can see, it's got a fair amount of bits and pieces missing from over here. I'm not sure, these are actually, thinking about it, they're not actually missing. Well, they are missing. They're battery packs. That's where the battery packs go. But all the rest of the main components appear to be there. But this has got there's bits of jumper wire. I'm not sure if they're normal because I haven't looked at the others yet. But I've had a look at the manual for this. Managed to get hold of a manual for this, and the circuit diagram isn't that complicated. So I'm hoping that with a bit of checking and testing, possibly the replacement of a capacitor, although I can't see any big electrolytics on here that are likely, other than this one here, which may have failed, that it could well be that this one is fairly usable. The display is all still there, so even if I can't get this one working, and to be honest, I think I might leave this one to last because it looks like it's got bird poo on it, and I think that's the one I would probably not want to try and resurrect. But the front panel of it is all there. The buttons, as the switches work, the connectors are there, the on-off switch functions. The circuit board is a bit mucky, but I think it just probably, it could well be that one is the one that actually works, but I need to clean it first. Let's put that one to one side for now. This one here has got the front, let's just take that up there out of the way a minute, the front glass missing. Now, although it's a big meter wide here, it actually is only 3.5 digits of LEDs on the front, so it only goes to 1999 maximum. So it was you know, in its day, a very general purpose multimeter, a bit like you can pick up multimeters. But I quite like the idea of having something fixed on the bench permanently, so I can just look over at it and use it for measuring. It's got AC, DC, etc. ranges down to 200 ohms. There was a low ohms version of it, which I probably wouldn't need to worry about, but it's got quite an impressive specification for its day. And this one here, which looks to be like it was in use, it's the cleanest of the bunch, but it's got these not calibrated and labels over the front. And it's got do not use for precision readings, not calibrated on 20 volt M, whatever that means. Warning, this equipment must be earthed. Yes, because there's a lot of metalwork in there, there was a need for it to be earthed. So hopefully 1 out of 3 won't be too bad. So I'm going to actually have a look at this one first. It's got a label on it there. It's an old disc label on there, disc write protect on there, and can't really see what it says on there. Something about 200 volts, maybe 220 volts range. So let's just have a little look at that one first. Let's put these two out of the way. So I'm hoping that we can indeed make one meter work out of all 3 of them. and hopefully we can get some kind of display up and running. The display is just a bit loose on this one, but the input voltages are there. So these the bench stand works. I mean, one of the things that I've got various other bits and pieces of equipment that I've done is oh, got that. Some of the things that I've done is I've had other bits of equipment which have needed quite a nice little case. So if at the end of the day I can't make this work, I've got a nice little case that I can build something into and just replace the front panel with a plain board of some kind. Anyway, it's going to be useful. There's no screw in that one, so it should, in fact there's no screws in any of them, I don't think. So if we just pull that out, we should be able to just withdraw the main board out. Well and truly wedged in there. There we go. Right, well, it's obviously had some work done because some connections here which are on the presumably the mains transformer, so probably it may be that it's been used for spare parts, and also one of the LEDs on the front has been removed, so that's something else. So this is, oh yeah, and two of the chips have gone. So this one has probably been stripped for spare parts. This one's got a different power side, so there are several different versions of this. Now this is revision AB on the circuit board. Let's just go overhead so you can see that. So we can see that it says revision AB. This old one over here that's in a lot worse condition, as it were, that's a revision Y. That's an 8000A 3011. This is a 3001. It could just be, of course, that all three of these have been stripped for spares in some way or other, and consequently not any of them are going to work. I'm not going to put any kind of mains power into any of these until I've given it a good visual inspection and checked for any leaky electrolytics. There we are. Actually, that's the way it should come out. So, and that's got a bit of, oh, what's that falling out? Oh, a bit of a rubber, something or other. Okay, so let's put that over there. Right, so this is another revision 3001, but it looks really nice and clean. Yeah, the capacitors, I think they could probably do with changing. They've got a wrap, as you can see in this older one, the wrapping has come off. These have got like a wrapping of the plastic around them, and they've not leaked as such, but that wrapping is not as tight as it once was, I shouldn't think. But anyway, we should just need to do a quick little check. Well, I think probably this one being the cleanest, circuit board looks like it's all in place. So I think we're going to start with that one, and we'll put these two to one side. So just check for anything. These shunts and that all seem to be in good order. It's remarkably clean. Chips all look quite good. They're digital chips, 7614, 7617 and 7447, and those two are, I think they're resistor arrays, I'm not sure. Anyway, let's just cast our test meter over these capacitors, make sure there's no shorts. And that's going up into the kiloohms range, as is that one. As is that one. Right, that's just as that came out of this box. Let's just check underneath, so we can see on here it's actually set for 230 volts. So let's just make sure there's no shorts to ground. We'll assume that that's going to be ground on that big piece of metalwork there. And we've got 500 ohms and climbing. Same there, same there. So these are bridge rectified diodes, I think, yeah. Well, there's only 6. That doesn't look right. There should be, oh hang on, it depends on the variation. Right, I think I'm going to risk it. I think I'm going to risk, see if it will come on. Before I do, I'm just going to take that glass off of there. It looks like it's been just stuffed back on there. Doesn't look like it's fitted properly. And I can take it out and clean the legend off of there. So interesting the way that just sort of seems to put, oh I see, right. Yes, there's an interesting thing. On the back of the glass you've got these posts that stick out through there, and they go through these holes on here, and that's what holds the LEDs in the right position. So presumably we don't need to worry too much about that. Okie dokie. Right, let's see if we can get any magic smoke out of this, shall we? Takes a standard IEC cable. Another one of those little round bobbles there. I don't know quite what they are. I'm going to risk turning it on. So it's turned off at the minute, so let's just, right, so nothing there. Hey, look at that, it's working. So DC volts. Right, let's turn it off again for a minute. We are lucky, we are very, very lucky. Let's just get hold of, hey, I'm going to take the front glass off of this one, which we can do easily from the rear. There's 2 little plastic clips either side, so if I just bend that slightly and give it a push, the glass should come out. I say glass, plastic. I'll push it too hard. Oh, I see, where that's where these little back they look a bit like cannonballs with a little hole in the end. They actually hold the LED to that glass. So let's take them off of there. And once you take them off there, then the glass will pop out easily. There we go. Right, learn something new every day. A little bit of cloth. Just give that a little bit of cloth with a bit of glass cleaner. Right, and and it goes in that way around because it's got like one edge chamfered off there. So we pop that into place. And then we put the display into place behind it and secure it with these little plastic, little, yeah, blobs, what you would call them. That one's quite loose. Let's see if one of the others fits a little bit better. Yeah. Perhaps there's a little bit of glue required of some kind. But anyway, it's working at the moment, it's holding it in place. So, bring it down here, let's plug it back in again. And switch it on. And it says plus 199.9. Wowza. We have a test meter. So, we need some probes, and we need here's my secondary bench power supply probes, so we'll plug them into there. And we'll get the power supply, and we're set to DC voltage 20 volt range. So presumably that goes up to 19.0. Negative supply to there. And we'll connect our test meter with it as well. Let's go back to the wide camera, which probably can't see much. And we'll connect that to there. We'll turn the power supply on, and we'll set it for 5 volts to start with. We'll just check, and we've got if I connect it to the power supply, it would read a lot better, wouldn't it? 5 volts thereabouts. Just make sure we're not going to get, we're just getting millivolts on there, we're not getting any volts. So we got 5 volts on my meter, 4.94 on the Fluke. So it is reading voltage. Let's just put a little mag up there so we can see that. Now, I don't know whether the overhead camera is going to be able to see both. Oh yeah. There we go, so we should be able to go back to that for a better view. We'll just try and do a little bit better focus on the Fluke. There we go. So we'll turn the volts up. 6 volts. 7, 8, 9. We can get that to dead on 10 on my meter. Of course, there's no guarantee that my meter is absolutely 100% accurate. But it's as near as down it's going to be. Oh, such a tickling the fine control. So 10. So that's reading 9.8 on the Fluke. So obviously the Fluke needs adjusting. So let's see if we can have a little look at the calibration procedure for the Fluke and see what's required. One moment please, as good old Clive would say. Taken to saying that a lot. Right, we're back with this multimeter. I've now found the area of the manual that tells me all about calibration. I'm not going to go into all the details, but basically there's a lot of calibration that you can do, and if we have a look at the diagram that it shows, down the edge of the meter we have some pots there that we can use to set the calibration for them. So the one we'll be interested in is the second one along. It says 200 millivolts DC. So if we come back up to here on the table, it says DC 200 millivolts, input 190 millivolts. And if we go back to the bench, we can see that I've reduced my power supply. It's been running for a little while to get it nice and warm. 189.9 I can get on my Vicky meter. I'll just keep tapping that control slightly. Obviously if you're going to do any serious calibration, really what you need to do is turn your power supply on, your voltage source, whatever, and let it get up to good temperature, because as you can see at such low voltages that it's varying slightly. I'm still trying to get it to adjust. So there we are, it's about 190. But if you leave it there, you'll see that it will fluctuate slightly. It's dropping down there. It's not a calibrated bench power supply in any way, shape or form. My meter's not right in that respect. But we can see there that we have got 190, but on the Fluke we've got 186.9. So I should be able to, and I can see the pot here, I should be able to hopefully just gently adjust this to give us 190 volts on the meter. I'm just creasing it up slightly. 187. We're going down. 188, 180. I'll keep turning it. 189. 190. So we've actually got quite a fine adjustment on there, but you see on my meter it's actually dropped down to 189. It's fluctuating. That's my bench power supply, so that's going to be good enough for me. If I go back to the 2 volt range, I input 1.9 volts and adjust the 2 volt range. So let's go back to that. Let's turn up, let's go to the 2 volt range, and then we'll put into it, what does it say, 1.9 volts. So let's turn this up to 1.9 volts. And then do the fine adjustment to get it on my Vicky to 1.9. All I can see is 1.9 on the bench power supply. It doesn't go any detailed than that, but the Vicky shows it down to 3 decimal places. I keep dropping that down there, a little bit too far. Obviously in a calibration house they would have digital calibrated test power supplies. That's going to be as close as I'm going to get. And on the meter you can see it says 1.908. So the 2 volt DC range is this pot here. Let's turn that down so we get nearly the same sort of volts reading. Right, now obviously on this meter it's going to be old, components are going to be worn, but it's working. It's doing the job that I wanted it to do. I just wanted it to be a general test meter that I can have on the side of the bench. I can put it out of the way. It doesn't need to be on show or anything like that, but it would just give me a quick little bench test meter for various testings. Now obviously I can go through and check and test other things, but at the moment it seems to be working, and I'm really pleased with that. That's really actually quite, for 20 quid I've got myself another meter, albeit an old one, albeit in reasonable condition. So what I'm going to do is I'm going to give it a bit of a clean up, put it back together, do a quick little check with some of the other values, and then have a look at and see if the other meter that was in sort of reasonable condition might be worth trying to get that going as well. But we've got 1 out of 3, which is not bad. So back in a bit. So there we are. Meter has been cleaned up, and a little bit of extra calibration on the ohms range, which I did, and that seems to be working. I'm not too worried about amps and high voltage, because I don't know whether I'll be using it for that, but I have tested it and it does read okay up on the AC and the DC ranges, so I'm quite happy with that. Cleaned it all up a little bit, and it looks quite nice. The only thing I didn't have with any of those meters was some test probes. It just so happens I've got a spare test meter, and it came with some quite nice long probes, but as is typical with test meter probes these days, they come in a shrouded plug, so I'm going to have to cut those so they will go into the connector, and hopefully the inner part will be the same as that. So bear with me a second while I just trim those down. So there we are. I've trimmed the sleeves down, and also on the banana part, just open those just slightly to give them a bit better grip on the connectors. They both fit in there quite nicely, and we're on the 20 volt range. So I've got a 9 volt meter, and there we've got 9.99 volts. Pretty happy with that. So as a little bench test meter, just for quick tests, so I can keep that one out of the way. It'll just be nice to have that there ready to use when I need it. Right, so that's the end of part 1. So hopefully we can now move on to one of the other meters and see if we can get a second one working out of the other 2. One I'm pretty sure we won't, and the other one looks a bit iffy because there's bits missing. So it's going to take a while, but stick with me. Thanks for watching. See you soon.